Build low-cost 3D Delta printer using Fused Deposition Modeling technology. Abstract Additive Manufacturing, AM, or 3D printing is becoming more common around the world, covering almost the entire mechanical field. This paper presents the process of manufacturing a 3D Delta printers via Fused Deposition Modeling, FDM, using unexpansive materials. The 3D physical prototypes can dissolve the solid material into a liquid and then they build layers on top of each other to give the final form. Originally 3D printing was invented by Charles W. Chuck, 1984. 7:1. The 3D Delta has 3 arms on the rails, moving up and down independently, controlling the head of the printer. This process is called the Cartesian coordinate system. Also it uses trigonometric functions based on the angle, which allow the arms to create and determine the precise location of the print head within the 3D print space. Delta printers have many advantages compared to other Cartesian printers such as, combining speed, accuracy, and cheaper assembly made. Keywords: additive manufacturing, Delta printer, Fused Deposition Modeling, Cartesian system. Introduction. Recently, Arduino and RepRap communities have had an increasing progress. Those devices consider as open source development model, and the projects designed by these devices are considered to be under the umbrella of the GNU General Public License. This allows all users to have quick access and continuous improvement of these devices. The objectives of this process are to produce 3D printers that can reproduce themselves and use an open source software for everyone. The Delta 3D printers DeltaBots are distinct from the rest of other Cartesian printers as it is printers use a radically different architecture for their 3D positioning system. Cartesian system can be described as a coordinate system that identifies any point in a plane with a distinctive way across a set of numerical coordinates which employ distances to the point from 2 fixed perpendicular oriented lines, dignified in the same unit of length. Where the x-axis moves horizontally forward or backwards, and the y-axis moves vertically in the left or right direction, and the z-axis moves up or down. Delta 3D printer also uses 3 control arms that are respectively named X, Y, and Z which connected to the print head to control the positioning of the print head. The Delta has light axes and thus produce greater speed and precision as well as a non-moving build platform, so it does not require moving the build platform to build the form, resulting in inaccurate printing and the appearance of distortions in the model, especially if the model is of high length. Delta printing on conventional printers requires other printers to have a move rule, which all depends on the threaded rods and nuts which limits its speed, but makes it is easier to maintain because of the spaces between the moving parts. This printer is controlled using 2 printed circuit boards, PCB. First board is a microcontroller, Arduino, and the other covers the power electronics. Regarding the Arduino is a flexible-based platform, which makes using hardware and software easy. Block diagram. 2 working. A mechanical build. Wood and steel were selected as basic materials for the construction of the model. Wood is chosen because it is easy to form and modify, and the steel because it is a cheap and available force. Several devices and components were purchased. Starting with the 14 mm thickness wood panels were cut according to the designs to build the base, roof, hinges and head of the printer and then make the cavities necessary to pass the wires and install the end stops. After that the 3 motors are installed in the machine roof, the end of the brake and the material carrier used for printing. Then the steel bars were fixed to build the base axes X, Y, and Z, a fire that openings were sealed with a plastic board. Later the arms were assembled and connected to the hinges using screws and then the arms are connected to the printer's head. The arms of each of the 3 sides meet in the middle where the hot end is connected. Finally the belts are connected with the wheels, the motors, and the final form assembly of the printer. B. Electrical build. The electronic construction has been done after many devices have been assembled and connected to each other and these devices are 11X Arduino Mega 2560 microcontroller board. 21X Ramps 1.4 set that's complete. 3x high torque hybrid stepper motors SY42 STH47_1684A. 4G 3D printer accessories 3D printer head 3D print head Mk8 extruder full metal. 5.1x LCD and SD card panel with plugs into the ramps. 6.3x mechanical end stops. 7 Minbo 12V20A surveillance camera LED universal 240W centralized power supply aluminum housing mesh switching power supply. 8 heated bed PCB MK2Y 200mm, 12V. 9 a good selection of cables. Starting with the Arduino panel was equipped with the motor drivers in the Arduino panel according to the datasheet instructions and then connected the 4 motors with the Arduino panel. After that the end stops are connected with the Arduino panel and LCD screens, the board was connected to the power source. The Arduino was connected through a USB connection to the computer to load the application on it. It can be noted that after building the prototype of a 3-dimensional printer, the pieces can be printed to replace the wooden and plastic parts used to produce the first printer. A new printer, and this type is called RepRap, self-replicating rapid pour, 3D printers 2. Steps per millimeter. Steps per millimeter calculate the number of electrical pulses, one for each step, sent through microcontroller Arduino to the motor driver to get the desired distance in the end. There are generally 2 equations for calculating steps per millimeter. One to calculate the movement of the axes X, Y, and Z. Steps per mm equals, motor steps per rev * driver micro step, / belt pitch * pulley number of teeth, 2. 2 to control the flow of printed material from the extruder. Extruder steps per mm equals motor steps per rev * driver micro step, * big gear teeth / small gear teeth. Drive pulley effective diameter * pi, 1. Figure 2 real Arduino wiring for 3D printer. See software and programming. 3 programs have been selected to complete the printing process. First program was used is Marlin firmware, which control the printer movement, and it contains wide options set inside. First, the measurements were entered such as the confirmed delta kinematics, steps per millimeter, the temperature of the hot end and other options. Then to use CAD program Google SketchUp, and this program is used to draw 3D models as mentioned earlier. Finally CAM program KeySlicer, which used to run the machine and print format, is equipped with control options via G-code, and also by which the amendment in the form of printed layers which form G-code. G-code can be defined as a set of functions that are used to control different parts of the machine, and it's a text file that includes all of the machine instructions to build the file. The use of G-code is not limited to 3-dimensional printing machines but relies on a wide range of machines, such as CNC machines, and a new branch has been developed to accommodate 3-dimensional printers specifically. Checking the 3D printer. Checking stage comes after the building, wiring, and programming of the printer. Before the process of printing, make sure that all devices operate on the face required, if not may cause losing one of devices and must be replaced. Filament types and printing. 3D printing filament is the thermoplastic feedstock for fused deposition modeling 3D printers. The process of 3D printing filament goes across 3 stages, which are heating, extruding, and cooling to convert material used for printing plastic into a 3-dimensional form. PLA is the Marshall which used in printing. It has advantages such as easy to print, unexpansive, and it is also solid material. PLA melts at temperature of 180 to 230 C. It should be noted that the more common are diameter 1.75 mm or 3 mm. First step in 3D printing is to design a digital 3D model, which is simply the process of developing a mathematics representation of any surface of an object in 3 dimension through the usage of specialized software. CAD, computer-aided design, is used as a tool to develop such a model. Design slicing. Design slicing is the process where the 3D model will slicing vertically into many layers so that the printing process will be easier. These layers will be printed one atop the other until the 3D object is done. This can done using software called Slick 3R. It is an open source software. The slicing consists of many parts, namely: post-process. The 3D model, printed forms by FDM technology outweigh the edges where clear classes depending on the precise movement of the axes x/y, and homogenization of printed material except printers with a layer height below 20 microns, and therefore used for finishing operations after printing. Post-process used to can be easily seen by the disappearance of the edges between the layers to be glaze and gradients is prominent. Some of the most common methods of finishing a print are sandblasting, painting and polishing, polishing with tumbler and lighter/fire-based post-processing. Conclusion and future scope. There are still many issues to be improved upon in building a 3D delta model. The next step that can be done, like the speed of printing, could be improved by increasing the number of headers, nozzles, in the printer, but ultimately a more efficient way is needed. Also, for the finished product problem, the printing process must be complete without the need for complementary processes. Beside energy consumption, using less electricity consuming methods may needed to melt the plastics, to reduce the power consumption, and finally unhealthy atmospheric emissions. It is better to install the equipment for the processing of rising gases to make the environment healthier. 3D printing is a distinctive way for the industry because it prints the product according to the consumer's wishes. To be considered as a revolution in technology, and it will increase the popularity of the community to change many usual lineaments of the life.